In the previous videos, we saw that most of the websites use AES-GCM for encryption. But how does this work? In the AES-GCM, the GCM stands for Galois Counter Mode. So there are two words. The one is Galois and another is counter. We will currently study the counter. So the counter mode is the encryption mode of a block cipher, which is described in this image. So first of all, we take initialization vector and we encrypt it by the given block cipher. So we get a key stream 1. This key stream 1 is XORed with the plain text 1, and this gives us the ciphertext. Now we go back to our initialization vector. The initialization vector is incremented, so a 1 value is added to it and we get the next vector, and it is incremented from the previous one. Now we encrypt this to get key stream 2, and this key stream 2 is then XORed with the plain text 2 to get the ciphertext 2. Similarly, we increment the previous initialization vector and we get the new IV plus 2, which is incremented from the previous one. Now we encrypt it and we get key stream 3. Then we XOR this key stream 3 with the plain text 3 and we get the ciphertext 3. So this is how the counter mode works. Now we go to the next word, Galois, in the counter. So Galois is for finite field. Galois is for finite. So here finite field of order 2 to the power 128. Now G hash function is used to compute digest using operation in Galois field. So this is a hash function which is being used over here. So this GCM mode gives us the two functionality, that is integrity and confidentiality. So we get these both in one go. We now learn using the AES GCM mode. So first of all, we need a key. So we get random bytes and 16 bytes of the key. Then we need a nonce and we write get random bytes 16. Now we need the plain text. So we write get random bytes and let's say 100 bytes of the plain text. Now we initialize our cipher. So cipher is initialized as AES.new and we write here as key and the mode. So AES mode and we use the GCM mode. Then we write nonce equal to nonce. It means that we are using the above nonce as the nonce value. Now we write ciphertext and tag as cipher dot encrypt and digest, because AES GCM mode does two tasks in one go. It encrypts and it creates a tag to verify if there is any change during the communication. So we use encrypt and digest and we do it for the plain text. So we now print the ciphertext. Ciphertext is, and we print that tag is. Okay, print ciphertext, and similarly we write print tag. Now we just check if it is working fine or not. We see that it has given us output of the ciphertext and the tag both. Now we need to verify if this ciphertext is of the given plain text or not. So we get the decrypted text equal to, now we need to initialize a new cipher with the same parameters. So we write cipher2 equal to AES.new, and we write here key, and we write AES mode GCM. Then we write nonce equal to nonce. So decrypted text is equal to cipher2 dot decrypt and verify. So what do we need to verify? We need to verify the ciphertext and the tag. So we will decrypt the ciphertext and we will check if the tag is okay or not. And next we print the decrypted text is, and we write here print decrypted text. We also print the plain text. So print the plain text is, and print plain text. Okay, now we go and run this program. So it has given us the decrypted text like this. It means that our encryption is fine and this tag is also fine. So we can just check it once more. What we will do, we will change this ciphertext. So we will create a new ciphertext, modified ciphertext equal to get random bytes, and we get 100 random bytes over here. So we write here modified ciphertext, and we will see that it will give us an error. So you will see that it has raised the error that MAC check failed. MAC stands for message authentication code. So it is telling us that it has failed, and therefore this tag is not valid. So the message has been changed during the communication. So this is how you use the AES-GCM mode in the encryption.